Hi everyone! We learned that graphs of sine and cosine functions have the shape of a wave along the horizontal axis and consist of repeating patterns. In this video, we're going to talk about some of the important characteristics of these graphs. First, I'd like to talk about the y-intercepts of the sine and cosine graphs. From far away, these two waves look pretty much the same. But if we look closer, we're going to notice that the graph of the basic sine function crosses the vertical axis at the point 0, 0. So that's what we call the y-intercept of the graph. It crosses the y-axis at this point. And if we look at the graph of the basic cosine function, then we're going to notice that it crosses the y-axis at point 0, 1. And unless the graphs have been shifted, which we're going to talk about later, this is how we're going to recognize sine and cosine functions. If the y-intercept at the origin, it's going to be the sine function. And if the y-intercept is not at the origin, well, in this case it's 0, 1, then we're looking at the graph of the cosine function. So keep that in mind. Next, I'm going to use this arbitrary graph, which means that it can be either sine or cosine, doesn't matter, to talk about some of the important characteristics of the sine and cosine graphs. And the first two are the maximum and minimum points of the graph. So I don't think you're going to have a problem finding them. So the lowest are the minimum points, and the highest are the maximum points. The other important points on the graph are zeros. Zeros are where the graph crosses the horizontal axis. So on this sketch, I can see 3 zeros. At those places, the function value or y value is 0. That's where the name comes from. Next, very important characteristic of sine and cosine graph is a cycle. We already said that the graph consists of repeating patterns. Well, cycle is just one copy of that repeating pattern. So in other words, it's a portion of the graph that can be duplicated to obtain the entire graph. And cycle can start at any place on the graph. But there are some convenient places that we're going to use to identify cycles. One of them is the minimum. If I want to cut a piece of the graph that I can later copy and paste, and I make my first cut here at this place, where should be my second cut? Well, I'll have to cut it at the next minimum. And if I take this portion of the graph, I will be able to copy and paste it and recreate the entire graph. Do you see that? Well, that means that one cycle of a graph can be obtained if we go from minimum to minimum. How about if I start at maximum? How far do I need to go so that that portion of the graph is not too long or not too short, so that I can copy and paste it and recreate the entire graph? Well, I should go until the next maximum point. So this represents one portion of the graph that can be duplicated to obtain the entire graph. Well, that means that it's one cycle. And we have one more special point on the graph, that's 0. If I start at 0, how far do I go? If I go this far and start duplicating this portion, I will not get the correct graph, right? I will only have the hills. That means that I need to continue and also include this portion. Now I can see that if I take that piece, copy and paste it, I will get the entire graph. That means that this is also one cycle. I'm going to make a note of what we just talked about. So we basically saw that 3 convenient ways to obtain cycles are the following. We can go from min to min, from max to max, or we can start at 0, skip 1 0, and then stop at the third one, right? See how there are 3 zeros that are part of the cycle. And what's interesting is that no matter where we choose to start a cycle, its length is going to be always the same for the given graph. And that length is called period of the graph. So period is the length of one cycle, and it's constant for any cycle of a graph. So that means that it doesn't matter where we decide to start the cycle. And since the graph of sine and cosine functions consists of cycles that all have same length, or the period, those two functions are called periodic functions. Let's look at the example where we need to find the period of the function. And we're going to use this example to confirm that no matter what cycle we pick, the period is always going to be the same. So let's pick a cycle. Remember, we have three convenient options. We can start at minimum, maximum, or 0. So let's say I'm going to start at the 0, at pi over 2. Well, if that's the beginning of the cycle, the end of the cycle will be here. Remember, we have to skip 1 0 and then stop at the third one. So from here to here is going to be one cycle. But what is its length along the horizontal axis? In other words, what is its period? For that, think about a basic example. If I have a number line and I want to find how far it is from 2 to 7. Well, first of all, you don't really need to even make calculations here. You're going to probably say right away, well, it's 5 units, right? But if I ask you to write down an expression that allows me to obtain this number, what would you say? Well, you're probably going to say you have to take 7 and subtract 2. In other words, take number on the right and subtract number on the left to find the distance of this segment. That's exactly what we're going to do to calculate the period. To calculate the period, we're going to take the rightmost value and subtract the leftmost value. So for us, the rightmost value is 7 pi over 6, and the leftmost value is pi over 2. 7 pi over 6 minus pi over 2. To subtract these two fractions, they have to have same denominator, so I'm multiplying the second one by 3 on the top and on the bottom. That gives me 7 pi over 6 minus 3 pi over 6. And now as I subtract the numerators, I'll get 4 pi over 6. Now that fraction can be simplified. We can divide out 2, and we find that the period of this graph is 2 pi over 3. And again, this number represents the length of one cycle along the horizontal axis. But let's pick another cycle, just to confirm that no matter what cycle we pick, the period stays the same. Let's say we're going to start a cycle at this minimum value. Remember, if we start at minimum value, cycle ends at the next minimum value, so right here. So that's the cycle. To calculate its length, in other words, to find the period, we have to take the rightmost value, 5 pi over 3, and subtract the leftmost value, pi. 5 pi over 3 minus pi. To subtract pi, I'm going to put it over 1, and to create some denominators, I'm multiplying by 3 on the bottom and on the top. So that's 5 pi over 3 minus 3 pi over 3. That gives me 2 pi over 3. And that is the same answer that we got in the first case. And that illustrates that no matter what cycle we pick, its length or period is going to stay the same. And at this point, the good question would be to ask, what is the period of the basic sine and cosine functions? We learned how to identify cycles and calculate period by looking at the graph, so we can do this for these two basic sine and cosine graphs. And here's the hint. While we can choose where to start the cycle, minimum, maximum, or 0 point, it's always convenient to start the cycle at the y-intercept. In other words, for the sine function, I will start cycle here, and that is 0, right? And that means that I should end cycle at this 0. I skip 1 and I stop at the third one. And the reason why it's convenient to start cycle at the y-intercept is because now as I calculate period and I take the rightmost value, which is 2 pi, and subtract the leftmost value, well, along the x-axis, the leftmost value will be at 0. So we get 2 pi. So we just determined that the period of the basic sine function is 2 pi. Let's try it with cosine function. Again, I'm going to start cycle at the y-intercept. So in this case, it's the maximum point. And that means that the end of the cycle is at the next maximum point. So what is the most right value and the most left value? Well, there are 2 pi and zeros again. The period of the basic cosine function is 2 pi. Now, is that a coincidence that they're both 2 pi? No. We said that a cycle is the portion of the graph that can be copied and pasted to recreate the entire graph, so it means that once one cycle ends, the next one begins and everything kind of repeats again. In other words, for these two graphs, we can see that after 2 pi, cycle repeats. Well, this can also be observed if we look at the unit circle. Remember, on the unit circle, x and y coordinates of the points represents cosine and sine values of the corresponding angles. That's how we can find function values of angles as we sweep around the unit circle, from 0 to 2 pi. But what happens after that? As I keep rotating to obtain more angles, I can see that cosine and sine values, in other words, coordinates of those points, start repeating. So that means that when I make the second revolution and third and fourth, the function values for all those angles start repeating. In other words, when I make just one revolution from 0 to 2 pi, all those coordinates and therefore function values are different. But after that, sine and cosine values start repeat. So this is another way to see and understand that period of the basic sine and cosine functions is 2 pi. So we learned about basic sine and cosine functions and some of their important features, but these graphs or waves can look different. These waves may be higher or lower. The wave can be stretched or compressed, and all that will be reflected in the function that you're looking at. Well, in the next video, we're going to learn how exactly the graph can be transformed and how it's going to be reflected in the function.